everyone. Welcome back to today's episode, where we're diving into a fascinating force that's all around us: magnetism. Magnets are part of so many things we use daily: our refrigerators, headphones, speakers, even the hard drives in our computers. But the world of magnetism goes way beyond just sticking things to your fridge. Today, we're going to explore the magic behind magnetism, from the basics of how magnets work to the futuristic technology of maglev trains that use magnetism to literally float above the tracks. Ready to be pulled into the fascinating world of magnets? Let's go. Let's start with the basics. What exactly is magnetism? Magnetism is a force generated by electric charges in motion. It's what causes magnets to attract or repel each other, and it's one of the fundamental forces of nature. Magnetism occurs at the atomic level when tiny particles called electrons move around the nucleus of an atom. Some materials, like iron, nickel, and cobalt, have electrons that move in a way that allows them to align, creating a magnetic field. This alignment is what makes these materials magnetic. In other materials, the movement of electrons is more random, canceling out any magnetic effect. So, not everything is magnetic. It takes a special arrangement of atoms and electrons to create the magic of magnetism. Now let's break down how magnets actually work. Magnets have two poles, a north pole and a south pole. Opposite poles attract each other, while like poles repel. This is why two north poles or two south poles will push away from each other, but a north and a south pole will snap together. Magnets create an invisible area of force around them called a magnetic field. You can visualize this magnetic field with iron filings. If you sprinkle them around a magnet, they align to show the magnetic lines of force, which form arcs from one pole to the other. This field is what allows magnets to exert force on each other even without touching. So, the next time you hold two magnets together, think about it. The attraction or repulsion you feel is the result of billions of tiny electron movements at the atomic level, creating a powerful force field. Pretty cool, right? There are two main types of magnets we interact with: permanent magnets and electromagnets. Permanent magnets are what most of us think of when we hear the word magnet. These are the classic, fridge-sticking, toy-attracting magnets made from materials like iron or certain alloys. Once these materials are magnetized, they retain their magnetism for a long time, making them great for everyday use. Electromagnets are a bit different. They're magnets that can be turned on and off using electricity. When an electric current flows through a coil of wire, it generates a magnetic field. Wrap that coil around a piece of iron, and you've got an electromagnet. What's cool about electromagnets is that they're temporary. Turn off the electricity, and the magnetism disappears. This ability to control the magnetic field makes electromagnets essential in devices like MRI machines, electric motors, and, you guessed it, maglev trains. We'll get into that in a bit. Magnetism isn't just a scientific curiosity. It's actually behind a ton of technology that we use daily. Here are a few examples of how magnetism powers our everyday lives. Speakers and headphones. Magnets in speakers and headphones interact with electric currents to create vibrations, which produce sound. Hard drives. In computers, magnets are used to read and write data onto hard drives. The magnetic fields align tiny magnetic particles on the disk, encoding information. MRI machines. MRI, magnetic resonance imaging. Machines use strong magnets to create detailed images of the body, helping doctors see inside without invasive procedures. Electric motors. Electric motors rely on electromagnets to convert electrical energy into mechanical motion, making things like fans, blenders, and cars run. These are just a few examples, but magnetism truly powers countless tools and devices we rely on every day. Now, let's talk about one of the coolest uses of magnetism: maglev trains. Maglev stands for magnetic levitation, and it's exactly what it sounds like: trains that float above the tracks using magnetic forces. Maglev technology uses both electromagnets and superconductors to lift and propel trains at astonishing speeds, some of which can reach over 370 miles per hour. So how does it work? Maglev trains use powerful electromagnets on the track and on the train itself. The magnets on the train and the track are arranged so that they repel each other, which lifts the train slightly above the track, creating a cushion of air. This eliminates friction, allowing the train to travel at incredibly high speeds without the wear and tear that conventional trains experience. To propel the train forward, the magnetic field on the track is adjusted in a way that pulls and pushes the train along. Imagine if you could surf on magnetic waves. This is essentially what the maglev train is doing. But what keeps the train stable? Maglev systems carefully control the magnetic fields to ensure the train doesn't move too far from the center of the track. Sensors constantly adjust the magnetic field, making tiny changes to keep the train stable and in motion. This precise control is part of what makes maglev trains so safe and smooth. Maglev trains might sound like science fiction, but they're already being used in some countries, and the benefits are enormous. Speed. Without friction from wheels on rails, maglev trains can reach speeds that regular trains can't even dream of. This could mean much faster travel times, making commuting between cities quicker and more convenient. Energy efficiency. Maglev trains are surprisingly energy efficient as they use electricity rather than fossil fuels, and the lack of friction means less energy is wasted. Less maintenance. Since the train doesn't physically touch the track, wear and tear are minimized, reducing maintenance costs and making the technology more sustainable in the long run. The power of magnetism isn't just limited to maglev trains. There's a lot more potential in this field, and scientists are exploring how to use magnetism for future technology. Here are a few exciting areas. As we move toward faster, more powerful computers, researchers are looking into magnetic memory and quantum computing. Magnetic materials are used in high-capacity data storage, and new magnetic tech could make computing more efficient. In healthcare, magnetic fields are already used in diagnostics, like MRIs, but future applications might include targeted drug delivery. Imagine tiny magnetic particles carrying medicine directly to where it's needed, reducing side effects. Magnetism could play a role in propulsion systems for spacecraft, potentially reducing the need for fuel. Researchers are investigating magnetic propulsion as a cleaner, more efficient way to travel in space. Did you know that magnetism also plays a huge role in nature? Earth itself is a giant magnet thanks to the movement of molten iron in its core. Earth's magnetic field protects us from harmful solar radiation, essentially acting as a shield that deflects charged particles from the sun. Certain animals, like birds, use Earth's magnetic field for navigation. They have tiny magnetic particles in their bodies that help them sense magnetic fields, allowing them to migrate over vast distances with amazing accuracy. So next time you see birds flying south, you can thank magnetism for helping them find their way. So, that's the magic of magnetism. From the basic magnets on your fridge to high-speed maglev trains and even the magnetic field of our planet. Magnetism is an invisible force that shapes our world in ways we might not always realize. And as technology advances, who knows what other magnetic marvels we'll discover? Whether it's making our headphones sound great or revolutionizing travel with maglev trains, magnetism truly is one of nature's most fascinating forces. So next time you play with a magnet or see a compass point north, remember, you're witnessing a force that's as old as the universe itself. Thanks for tuning in. If you enjoyed this episode, share it with a friend who's as curious about science as you are. Until next time, stay curious and keep exploring the wonders of the world around you.